All right, so we have a graduated cylinder with 25.0 milliliters of water. That's known. We're going to add a solid, and the water level is going to rise to 33.9 milliliters. And the mass of the solid is 63.5 grams. What is its density? So there's a lot of knowns there. That's why we circled multiple things. Okay, and then we underlined our unknown because that means that's what our goal is, what we're trying to find. Now I'm going to draw some pictures here because there's a lot of details. Okay, we started with a graduated cylinder with just water, and it's at 25.0 milliliters. Now, when we added a solid, it went up to 33.9 milliliters. It didn't take the place of any of that 25. So I'm writing it like this, even if it sunk or floated or did something in between, we know that the mass of this solid has to be the subtraction of these two. And so that's just the picture to kind of put in your brain. So 33.9 milliliters minus 25.0 milliliters is going to give me the volume of the solid. So 33.9 minus 25.0 gives me 8.9 milliliters. Okay, now let's think about sig figs. Adding and subtracting goes by least decimal place. 1 decimal place, 1 decimal place. So my answer is going to be 1 decimal place. So it's actually already set up properly. So this is my volume of my solid. Okay? We're not worried about the volume of the water anymore because our goal is to find the density of the solid. Okay? So what do we have? We have the mass of the solid and the volume of the solid. Those are both our givens. So I'm just going to put a G here just to remind us where we are. Our unknown is what we're searching for. That's our density. Okay, and this way we can make sure that we have it organized in our brain. We have a mass and a volume for our given, and we have a density as our unknown. And then the next thing is E for equation. Well, I'm solving for density. There is only one equation. Density equals mass over volume. Okay. And then substitute solve sig figs. Mass, 63.5 grams, over volume, 8.9 milliliters. And let me double check. Density should always be in units of grams per milliliter or grams per centimeter cubed. Okay, that is right. If one of these was in like liters, before you even got to the substitute part, you would have to convert to milliliters. If this guy was in kilograms, you would have had to convert to grams before you went to the substitute phase. But since it's grams per milliliters, I can just stop right there. 63.5 divided by 8.9. That gives me 7.134831. That's the calculator answer. Sig figs again. 63.5, 3 sig figs. 8.9, 2 sig figs. 1, 2. The 3 says we're going to round down. 7.1 grams per milliliter. So always remember magnitude and units in everything that you are doing.